Everyone. Today we are going to deal with second assignment. The TA of the course has already selected this solution from one of the students, and today we will go in details about the solutions, and most importantly, I will talk about how to provide solutions specifically for midterm and final exams. If we face similar questions for midterm and final exam, the way we evaluate them could be totally different, because you will have 24 hours as a take-home exam to answer the questions, so it must be perfect. It should contain all the solutions with no errors. Even the final answer should be there, and there shouldn't be any miscalculation, because you should go through it again and again. So there shouldn't be any minor errors for midterm and final exam. But for assignments, we are just practicing them together. And specifically today, we will go through the details together to see how we can possibly provide the complete solution to each one of the questions. So for the first question, we asked you about union or intersection of limited number of sets, and we consider them as AI, and I starts from 1 goes to n, so natural numbers. Let's see how we can deal with that. So if you want to imagine what are the sets, we can start maybe like this from the first set. Say, for example, what is A1? It contains only the first element of natural numbers. A2 contains 2, and so on. And for part A, let's see what the student did. He or she considered union of all of these sets, or the same notation that they use in the question. They are the same. Then one by one, he or she tried to show it. But this is not the correct way to show it, because you see here we have infinite number of, not infinite, but n number of sets. But here I have only 4 number of sets. You see, so these two are not equal. We should be careful about these notations. I know these things are very simple, and sometimes we rush to write the final answer, but to make these mistakes in final and midterm, unfortunately, you will face decreasing points, and it will be very painful to lose points for such simple questions. Okay, for assignments, it's totally fine because we are practicing. But please make sure that you don't write things which don't make sense. For example, here, now suddenly we have 4 sets. So we should be careful. These two are not equal to each other. And here, the student concluded that the union of them is equal to this, which is the correct answer. But this is not the reason. The reason is that A1 is a subset of A2. A2 at the same time is a subset of A3, and so on. So in order to conclude that this is the final answer, you should say A1 is a subset of A2, and so on until we reach AN. So if you want to provide the complete solution, you should be careful about that, because this is not good enough for concluding that this is the final answer. And the same story for this one. Here, when we talk about the common element of all of these sets, yes, the final answer is correct. But again, we should show that they are subset of one another until AN, and that's the reason that A1 is the final answer for it. Okay, let's move on to the second question. This is also a simple question, but I observe many mistakes, so we should be careful about them as well. So we have a universal set. It means that all the sets should be defined inside this universal set. For example, we don't have negative values, or we don't have 0 in this universe. So what about part A? Size of A. What's the size of A? It's very easy. We see that A contains 3 elements, so this is 3 right away. What's the power set of A? This is not the correct answer. This one shows the size of the power set, not the power set itself. We asked you about the power set, okay? So in order to write the power set, you should include all the subsets of the set A. So it means that empty set, 1, 2, 5 separately, 1, 2 together, 2, 5 together, 1, 5 together, and the set itself. So 8 number of elements, you should list and write them completely. This is the size of it, which is good to calculate anyway, because I told you it shows you how many elements your set has. But the power set is not the number like this. It is a set itself, which contains all the possible subsets of A. So be careful about that. So what's the size of C? As you can see, here we have infinite number of elements. Whenever we have such a case, just directly write infinity. It means that we have infinite number of elements here. So usually in mathematics, whenever we deal with such sets, we consider it by this notation infinity. All right, next one. Part D, we asked about the complement of C, not C itself. We should be careful about the notations, okay? So C prime or C as a power, you can write another C to notate complement, or bar, maybe C bar, for example, you can show the complement like that. So be careful. Here we should write C bar, C prime, or C, or as a notation power C. So this one, the complement would be equal to U minus C. This is correct. But what's the final answer? The student didn't provide the final answer. So here we have the universal set, and we are asking about whatever is not inside C, but is inside universal set. What are they? So if C represents the odd numbers, so obviously C prime should be even numbers. And you don't include 0 inside it because we don't have 0 in the universal set. And not always we consider 0 as an even number. Usually we start from 2 anyway. So here we should be careful that you should write the set as well. Okay. And for A minus B, again, the answer is not correct because we are asking about the elements which are inside A, but not inside B. But B contains 1. So 1 shouldn't be inside this set. So the only elements A minus B should have is 2 and 5. It contains 2 elements only. Okay. So next one, B minus C. B minus C. Again, it shouldn't have 1 inside it. Fortunately, it doesn't here. So it contains 3 elements like this. Yes, that's correct. And all of them are even numbers. These are odd numbers. So for sure, we shouldn't decrease that. And if we ask about the power set of B minus C, this one is not equal to size of B minus C. I don't know why the student consider them equal, but there are different questions. Like if I consider absolute sign like 2 straight lines here, I ask you about the size of the power set, then yes. But if I ask you about the power set of B minus C, it means that first construct this set. Now I know it contains 3 elements. It has 8 elements inside this one. Yes, that's good to calculate, but this is not what I'm looking for. I'm looking for a set. It means that it contains 8 elements, start from empty set, then 10, 100, 1000, 10 and 100 together, 1000 and 100 together, 10 and 1000 together as pair, and the set itself. 8 elements. So you should write all of them inside the curly brackets and show it for B minus C, and that would be the correct answer. All right, let's move on to the easiest question of the second assignment about the composition of functions. Again, although it's very simple, but let me go through it in details. Maybe there might be some minor errors here as well. So composition of f, o, g, x. Whatever you have as an input here, you should be careful that you should express your final answer with respect to this. If this one is y, if this one is z, the final answer should be like that. If this is a value here, then assign the value inside the function. So first, I can represent it like this, that gx is an input of f. So I translate this one into this. So first I can write what is gx. Instead of y, now I consider x, so I will have e power x. So e power x as an input of fx, which is fx just decrease one value from. So it will be e power x minus 1 as the final answer. So to provide the complete solution for midterm or final, I doubt that I will ask such simple question for the midterm or final, but anyway, if that's the case, then you should provide the complete solution. Like for example, this one even is important. Okay, so part B, f, o, g, o, h, and the input is y. So starting from hy, instead of z, I just consider y minus 1 over y. Insert instead of gy, so I will have e power y minus 1 over y, and the whole thing just decrease one value in fx, and that's the final answer. So one by one I inserted the function inside one another. So hy I calculate, then as an input I consider for g, and then the whole thing as the input of f, which means that just decrease it by minus 1, as this is what this function does. Part C, now I have value instead of x, y, z, or whatever variables. So it means that you can consider x at the beginning and then assign 2, or assign 2 directly to it. So if I have x minus 1, it will be 2 minus 1, which is 1 right away. So for g, I just insert 1 inside it, and instead of e power variable, I will have e power 1, and the final answer is the number e. And don't forget, e is a number, not a variable. It's an irrational number, and you should be careful not to mix it with variable. Okay, for next one, again we insert value instead of variable. This one is again very easy, I guess. There shouldn't be any problem with it, but if you like, I go through it anyway. So minus 2 instead of x, so we will have minus 3, and minus 3 inside the function g, then I will have e minus 3 power minus 3. So for the last one, again, composition of 3 functions together, you already know how to represent them. So first start with the input of h. So first solve this one, then this one for f, and then the whole thing. So first, when I insert inside the h function, I will get 1 minus 1, which is 0, over 1, which is 0. Then insert it inside f. So f always decrease one value from that variable. So it will be minus 1. And finally, when you insert it inside the g, oh, sorry, it was, let me see again. Yes, true. Minus 1. And then at the end, you power it by that one, and you will see e minus 1. Okay, guys, it's okay to practice it with different softwares and have some errors in the assignments, as I told you. TA will give you feedback accordingly. But as you see, even in the answer key that the teaching assistant provided, there are some errors. For example, if it was the answer for the midterm exam, it will have many negative points, and the grade wouldn't be good for these solutions. But for assignments, it's okay. And we are practicing it together. And please be careful. Even if you get 100, it doesn't mean that all your answers were correct. Okay, guys, if you have any questions, please let me know. Otherwise, I will see you guys on Friday, and we will talk about the new topic.